All right, let's talk about something you probably learned a long, long time ago: angles. But I want you to forget everything you think you know, protractors, degrees, all of it. Because today we're going to look at angles in a totally new way, as what they really are: the story of a turn. So let's start with a little puzzle. What did these three things have in common? A clock, a Ferris wheel, and a simple pair of scissors. They seem pretty different, right? But there is one fundamental idea that connects all of them. And by the end of this, you're going to see it crystal clear. And that's exactly where we begin. It all starts with a simple turn. Before we get into any math, let's just focus on a physical action that every single one of us understands without even thinking about it. You remember playing statue when you were a kid, right? You'd spin around and then just freeze. Well, that simple action, turning your body, that's the key to understanding literally everything about angles. It's not about lines on a piece of paper. It's about movement. Okay, so if it's all about turns, how do we talk about them? We need a simple, common language to describe, how much of a turn we're making. Let's start with the big one: a full turn. This is the whole shebang. Think about the minute hand on a clock going all the way around in an hour. It makes a complete circle and ends up right back where it started. That's a full turn. Then you've got a half turn. Pretty simple, right? You just turn until you're facing the exact opposite direction. You've done a complete 180. Imagine you're tracing a perfect half circle on the floor with your foot. That's a half turn. And then we have the most important building block of them all: the quarter turn. It's exactly what it sounds like: halfway to a half turn. This is the turn we make all the time without even noticing, like when you're walking down the street and you turn a corner. So here's the cool part: we can describe all of these basic movements with really simple fractions. A full turn is 1, a half turn is 1/2, and a quarter turn is 1/4. See? No complicated math yet, just simple, intuitive ideas. Okay, so here's a quick question for you. Think about it. What happens if you make two of those quarter turns, one right after the other? And what about four of them? If you can answer that, you've basically got this whole concept down. All right, now we get to the magic moment. This is where we connect that simple physical idea of making a turn to the thing we all learned about in math class: an angle. And here's the big secret: it's so simple. Angles are just the language we use to measure a turn. That's it. An angle isn't a shape, it's a measurement of how much something has rotated. So, remember that quarter turn we talked about? Well, in the language of angles, we just give it a special name: a right angle. It's that perfect corner you see on a box or the edge of a book. A quarter turn is a right angle. Same thing, just a different name. And once you get that, everything else just clicks into place. Any turn that's less than a quarter turn, that makes what we call an acute angle. Think of a sharp, pointy shape. And any turn that's more than a quarter turn, that's an obtuse angle. Think of a wide open mouth. It's all based on that quarter turn. And hey, what about that question from a second ago? What's two quarter turns? Well, it's a half turn. And the angle it creates is called a straight angle because it makes a perfectly straight line. You've turned to face the complete opposite way. Okay, enough with the theory. Let's take this idea and actually use it. You're about to start seeing the world a little differently, because these turns, these angles, they are absolutely everywhere. I mean, just think about your average day: turning on a faucet, twisting the lid off a jar, opening a door, even using a pair of scissors. Every single one of these objects is built around the idea of a turn, and every time you use them, you are creating an angle. In fact, you can make a little angle viewer yourself really easily. Just take a piece of paper, fold it up like a fan, and voila! Open it up a tiny bit and you have an acute angle. Open it really wide, you've got an obtuse one. You're literally holding the idea of a turn in your hands. Of course, a turn isn't just about how much you turn, it's also about which way you turn. We call the direction a clock's hands move clockwise, and the opposite is, you guessed it, anti-clockwise. You tighten a screw clockwise, but you open a jar anti-clockwise. The direction really matters. All right, time for a little challenge. Look at this drawing of a house. Can you spot the angles? Think about where the wall meets the floor. That's a perfect quarter turn, a right angle. But what about the peak of the roof? Is that turn smaller or larger than a quarter turn? And this brings us to the most important part. Once you start seeing angles this way, not as static shapes, but as the result of a movement, you just can't unsee them. They start popping up everywhere you look. So, I want to leave you with this final thought. A turn is a movement. An angle is its memory. Every time you see an angle from now on, don't just see a shape. See the ghost of the turn that made it. It's a little piece of movement frozen in time. What turns will you spot today?